Hey folks, we're back at it again. Today we're going to be talking a little more about limits, but today we're going to be emphasizing on some of your favorite topic, trig. I know trig is not some people's favorite subject, but we do need to emphasize it because trig is a significant enough part of calculus that I need to make sure that we emphasize it. First off, let me briefly say, if you have managed to somehow forget the unit circle entirely, you need to go back and brush up on it because this is going to cause you to miss enough points that it's worth your while. The good news is, in terms of trig, you might remember that we had two different things that we were trying to constantly maintain, degrees and radians. Well, guess what? We've gotten rid of degrees. Degrees we say for, well, I don't know, temperature measurements and stuff like that. Everything that we're going to do is in terms of radians. Well, so good news there, I guess. Anyway, so today we're going to start off by this, and I'm going to say quickly copy both of these down because pretty much everything we're going to do for the rest of the day is based off of these two statements. Now, I'm going to emphasize the fact that in both cases, its limit as x approaches 0, so remember that. But copy this down, and I'll get started again in just a couple minutes. Yeah, freeze it. Patiently waiting. Still patiently waiting. Okay, I'm hoping you've gotten it down and you've frozen the screen as needed. Okay, now, I'm going to have people say, well, wait a second, how hard can that be if the only problem I ever have to do is write down 1 or 0? The reason why is because things don't always look like this. Let me take it for instance. Let's say I was to give you the limit as y approaches 0 of the sine of, let's say, I don't know, 6y over 6y. Well, I'm probably going to have one or two people say, okay, first off, Johnston, it's y, and y, not x, and x. And I'd say, yeah, you're right, but we can still do things. We can change variables. And I would also have somebody else say, well, wait a second, this is 6y and this is 6y as opposed to x and x. I've got coefficients there. And I'm going to say, you're very observant. Well done, you. But I also need to point out something else. Let's let x equal 6y for a second. Okay, if that's the case, then I can say that this is going to be the sine of x over x. And my limit, if x is approaching 0, well, if y is approaching 0 in my expression, I think x also has to be approaching 0. So guess what? We're looking at the same expression that I was up there. So it may look a little bit different, but as long as these two things match up and these two things match up, we can use these same sorts of properties. So keep that in mind as we move on. We're going to keep coming back to these two things over and over again. And I would say that probably most of the emphasis is going to be sine x over x, but there is going to be some cosine stuff. So let's take a look at our first example. Here we go. We got something nice and easy like this. And you're going to say, what am I supposed to do? You didn't say anything about squaring. And I'm going to say, you're right, but I could pretty easily rewrite this instead of saying just sine squared of x, that is sine of x times sine of x. And my denominator is just x and x there. So in other words, I could just say sine of x times sine of x. And again, using the property from the last session, we can say that, well, we know what the limit is of this as x approaches 0, and we know what the limit is of this as x approaches 0. Well, guess what? That's 1, and since I'm multiplying together those two expressions, I can multiply their limits, and I'm now looking at 1 as my answer. Yay me. All right, let's see what else we've got here. How about something like this? Now again, I mentioned this, and I'm going to come back to it. We really want this to match up perfectly with that. Well, that's not too difficult. All I have to do is put a 7 here, right? except I can't just put a 7 in the denominator. I have to do something that will counteract that multiplication of the denominator by 7, which would be multiplying the numerator through by 7. Okay. Now, for those of you that are having issues, remember, basically what I've done is I multiplied by 7 over 7, which is the same thing as multiplying by 1. So this is fully legal, and I just might make it look like that so it's a little bit prettier. And now I can look at the limit of this expression, which we know is 0, times 7, and I'm now looking at 0 there. Cool. All right, well, I've got my answer. Yay, ready to move on. And I'm going to get to this one. And I'm going to have a couple people that are extremely anxious, and they're going to immediately say, wait a second, I recognize that. That was this right here. So I already know what my answer is. So, Mr. Johnston, I am 100% ready to put this down as being 0. And I'm going to say, nice try, but no. Wait a second, what's wrong? What went wrong in this process here? I thought that that was true. It is true, except that there's one little difference between what I've got here and what I've got there. Here, there. The one little thing you need to notice is here, x is approaching 0. Here, x is approaching pi. So that whole memorized thing does not apply in this case. Well, what are you supposed to do? Well, we're just going to use the same thing that we always do when in doubt. Direct substitution. So I'm going to say it's going to be 1 minus the cosine of pi over pi, at which point, those of you that managed to forget the unit circle, you need to brush up on it. What is the cosine of pi? I'm waiting. No, it's not the square root of 3 over 2. It's going to be -1. So we're now looking at minus a negative, same thing as plus a positive, and it's 2 over pi. Okay, well, that was kind of nasty and mean-spirited, but hey, I'm a math teacher. I'm supposed to do stuff like that. Let's take a look at one more. One final example. Please copy this one down. I am assuming that there are going to be people that are going to say, it doesn't look like either one of these, Mr. Johnston. And I'm going to say, you're right, but I'm going to do one thing to make it look a little bit better. Once again, it's a limit. And by the way, folks, please always do limits until you do your substitution. If you don't write down the limit, I will tell you that many colleges will instantly start taking off 100% of the points the minute you don't write down the limit. And since this is a college class, guess what? We got to do about the same. So I'm looking at this. Is what I've done at this point legal? I'm hoping that people would agree that your answer is yes there. Okay, now what I really would like to do on this one, and I'm hoping people are okay with that, I want this expression to become 5x, the sine of 5x over 5x, because I know what this value is then. Well, oh wait, I can't just divide through by 5x, so I also need to multiply through by 5x, but that's legal now. And I'm going to want to do the same thing here because I've got 2x, and I'm going to say 2x here, at which point I'm going to have one or two people politely freaking out because you're sort of like, what the heck is that? That's not one of these. And I'm going to say, yes, it is, sort of, because I'm going to say the limit as sine x, or sine of 2x over 2x as x approaches 0. Everybody at this point would agree that that's going to be 1. Well, what happens if I flip everything over? The limit as x approaches 0 of 2x over the sine of 2x, guess what? I'm going to flip over my answer too. And that's just 1 over 1, and that's going to get me 1 over 1, so it's just 1. So don't freak on that one. It's not too exciting. Anyway, so let me get back to this stuff, marking this up, and I'm now looking at still writing out the limit as x approaches 0 because I haven't done any direct substitution yet I know that the sine of 5x over 5x is 1. I know that 2x over the sine of 2x is 1, and I've got 1 over 2x there. So I multiply this out, saying the limit as x approaches 0 of 5x over 2x. Oh, wait a second, I can cancel my x's. And so I'm going to say that that's going to be 5 halves, and when I go to plug in the x of 0, there's no place to plug it, and I got 5 halves. And I'm going to say, yes, you do, well done. At which point, some really, really snarky person in the back row is going to say, wait a second, I told you that at the beginning. And I'm going to say, yes, you probably could have, but this is a math class, and it's not about the answer. It's about the work that gets you to the answer, okay? We really need you to be emphasizing the process that's involved. So I will tell you right now, most people can jump straight from here to here, but to have all the work to justify that, that's where the points are. Because if you go straight from the beginning to the end, that's worth nothing to me. Please make sure that you're showing your work. Okay, so what would I say at this point? I'm going to emphasize kind of these 3 things. You can expand factored expressions. You can factor expanded expressions and flip-flop these things. Okay, that's okay. You can separate fractions into a numerator and denominator, and you can factor to set up canceling. Those are the main ones that people use. So now I got you an exit slip to try and mess with and practice on. I am hoping that things go well for you, and if not, I will look forward to seeing you in class very, very soon. Have a lovely rest of your evening, and we will talk later. Take care. Adios.